Okay. So, first, let us consider a system which we already know some things about. It's always easier to start with systems we know things about. So, suppose we have this system. It's nothing but two states. State 1, state 2. It can be anything. Now, the interesting thing is, we know some things about these states. So, what do we know? I say, we know that they are wave functions. So, this state has a wave function psi 2, and this state has a wave function psi 1. Now, for simplicity, or rather for the time being, just take it for granted that I say this is the zeroth wave function. Now, what do I mean by the zeroth wave function? I will come after some time. But for the time being, consider that these are two wave functions which we already know. Okay. And these two are orthogonal to each other, and they form a complete basis. So what does a complete basis mean? It means that summation of the ket and bra of the two states will give me something known as the identity limit. Saying we don't need that concept as of now. I'm just explaining. Now, these are the eigenfunctions of the Hamiltonian H0. So, if I say that these states are the eigenfunctions of this Hamiltonian over here, I can easily write down that H0 of psi 1 will give me something called E01 psi 1. Similarly, H of 0 psi 2 will give me something as E20 psi 20. So, try to visualize what I have done over here. This is a state. I know its energy is E1. This is another state. I know that its energy is E2. Fine? This is all I have done so far. Okay. Now, if I try to find out the energy difference between these two systems, I will write something as delta U. Okay. Now suppose I want to look how the energy is changing with respect to how we move the systems. What can we do? The easiest thing we can do is I can write del E is equal to E20 minus E10. Okay. Now suppose I try to draw the fluctuations in energy and see how do things change. Okay. So suppose I label this part as energy E and this axis as delta. So as delta E increases, how do these E20s and the E10s they fluctuate? So to see, or rather do the maths, what we can do is del E is along the x-axis. Right? I fix one of the levels. Suppose I fix this level and move this thing up. So I fluctuate this thing, moving it up. So how will the energy of E20 fluctuate? All this is y minus E10. So y can be written something like this. Fine. Y is equal to mx plus c, m is equal to 1. Slope is equal to 1 and it is not passing through the whole. So this thing, for now, I am saying that this is, let this not be the origin. It is something which I don't know. I can label this as T2. Same thing I can do with E1. But this time the slope will be a minus m. I get something like this. There you go. Yes. So that intercept over there, what was the intercept? E10. So this point over here is E10. When this E10 is fixed, and the same point is E20. And this is fixed. Right? Now, try to imagine this distance being less. These two states essentially become so close to each other that we can say that they are actually going towards the same state. A single state. That's why at this point when delta E is 0, E10 and E20 are equal to each other. So essentially I can take this point to be the origin. You understand why? They're essentially going to the same state, so delta E is going to 0. Understand why can I actually take this to be 0? Why it is mathematically 0? When I tried to plot it, I had fixed these states and plotted. Understand what I am saying? Ball, down from the ball. Picturing systems can be a bit difficult, and I am trying to do that. Why there? Here, you put this. Ball you mustaches. ঠিকঠাক তো কেনটা 0 হচ্ছে আচ্ছা another interesting part over here is this line is actually continuing over. I have not written this line is actually continuing over here. This is continuing over here. This is just equation of a state, right? I have not drawn it here so far. Okay? This is just the basic things which we know about the system right now. And this system is a two-level system. We know the Hamiltonian, we know the wave function. Now comes the interesting. So, we want to look at a system where these two are interacting with each other. So, what am I trying to do? It is a stable system, I know everything about it. I am disrupting the system. I am giving some disruptive force from outside which is causing these two systems to disrupt. Maybe it is going up, maybe it is going down, something I don't know what is happening. I have just given a disturbance from the outside. Now, if you are looking at chemicals, what sort of disturbance are you mainly accustomed with? We can give heat, we can give light, we can give a magnetic field. কটা বাজে বল? একটা 45 মিনিট লাগবে। So, I'm disrupting the system with maybe light, maybe a magnetic field, maybe heat, anything. It's up to me. But for now, this is a two-level system and I have different. Okay. So the moment I disrupt this system, say my new system is a certain psi, which can be written as alpha of psi 10 plus alpha 2 of psi 0. Is it fine? Wave function of the total system. Disrupted. Now these alpha 1 and alpha 2 can be constant depending on what the system will end up or at what position the system is right now. So, ডেস্কটপ করে দিচ্ছি তো দেখ ভালো করে এই দুটো লেভেল এবার কি হচ্ছে ওপর নিচে হচ্ছে একটা সার্টেন জায়গায় গিয়ে আমার টোটাল সিস্টেমটাকে আমি ডেসক্রাইব করতে পারবো সেই পয়েন্টটাই আলফা 1 আর আলফা 2 এর উপর ডিপেন্ড করবে ফর ডিফারেন্ট স্ন্যাপশটস দিস আলফা 1 and alpha 2 will be different dynamic system এখন আমি ডিসরাপ্ট করতে চাচ্ছি ঠিক আছে and now the Hamiltonian of this system, will be my original Hamiltonian, the Hamiltonian which I already knew, plus a certain perturbation. Now this perturbation is external and I know this perturbation. Because I am the one who has given it. So I know H1, I know H0, and I know H. Okay. So once these things are given to me, I now try to describe how this system will evolve. Okay. So we do something very trivial. We take this. Have what? H1 টা আমরা কাটি দিচ্ছি H0 টা আমার ইনিশিয়াল সিস্টেমের ছিল যখন আমি পার্টারনেশন দিই I had not given the perturbation then the system was being defined by the Hamiltonian H0 once I give the perturbation H1 now the system will be defined by the Hamiltonian of H0 plus H1 fine okay so now something very trivial we write H psi equals to E psi and try solving this. So if I write H psi equal to E psi, plug in this equation, let me call this equation 1 into this equation 2. So what do I get? I get something like something like this. I just taken this to this side, factor is fine. Okay. Now an important thing to note over here is
This is the wave function. function, we are considering that it is also eigenfunction of the total Hamiltonian.
Yeah, the total wave function will be the eigenfunction of the total Hamiltonian. The total system, which I have defined by this, has to be a function of the total Hamiltonian H.
Because আমি এইচটা জানি, because আমি এক্সটার্নাল পার্টিশনের জেকে দিয়েছি আর ওটা অলরেডি ডিসটেন্স করার পরে ফাংশন
আমি যদি না জানি এটা তাহলে তাই টোটালি ব্যাপারটা
H is a big Hamiltonian for the total system. Like we find H that H shall will be equal to H. Yes. Acha, I understand your question. Okay. What he is asking over here, I had a system H0. I give a perturbation H1. How can I be sure that the final Hamiltonian I am getting will be an eigenfunction? How can we be sure about that?
Because we are defining H as that.
I am defining this Hamiltonian to be something like this.
Which will always be an eigen operator related to sign.
I am saying that, but when will it be? You have to find that out.
Conditions.
You have to find the conditions, right? You understand? You understood this question and what I said? Huh? Today what is this? Condition এর একটা বার করতে হবে যেখানে এই বড় হ্যামিলটনিয়ানটা আমরা সাইড সলভ করতে পারবো তো এফেক্টিভলি যদি ইকুয়েশনটা সলভ করতে হবে if I solve this equation I will get the related conditions out of this equation fine well fine क्या होगा ठीक है अच्छा now taking your question into consideration, if this was to happen, this has to happen. So this should be true no matter what. So what I do is, I do a trick. Okay, so before that, you people can understand over here that H is an operator and E is a constant. This is important. H is an operator. So H operates on psi10 gives me back something. It can be psi10, but most probably it won't be psi10 because this is not an identical equation for psi10. H0 is the identical equation for psi10. This is H. So all in all chances it won't be an identical equation anymore. Okay. So I use another common trick prevalent in quantum mechanics. I left multiply which I want to start this whole equation and integrate it over all space. You people have done it before? Okay? I've left multiplying psi10 to this equation and integrating it over all space. Okay. So by now I will be using bracket notation and I think you people have been accustomed to bracket notation. Not much, okay, I won't be using a lot of bracket notation. So alpha 1. So what I am doing, I am multiplying psi10 square from here and integrating. So first things first, alpha 1 does nothing, so it's a constant multiplier, so it goes up, psi10 goes in, gets H. Now this H operates on this. So I'll get something as something like this. This is what? Integration psi10 H operating on psi10 and integrating it over one space. Right? Minus E is a constant. psi10 star integration over all space. What does it give me? What does 1? Good. E, the constant is out, right? Mathematics is fine. Plus, the same thing with alpha 2. This is correct because now from this Hamiltonian, you can operate on psi 2 0 and psi 1 0 is left multiplied and integrated to a cross space. But since h psi 2 0 and psi 1 0 are orthogonal to each other, if E comes out, we do integration, we get a 0. So far so good. So far so good. Okay. Now to make my life easy, I will denote this as H11. So this left one stands for this left one, this one stands for this. So this number, or rather this integral, I will denote it as H11. So what will the name of this integral? H12. I'm just naming these to make my life easy. I don't want to write big integrals, therefore I'm just giving it a name, which is easier to understand. Okay. Similarly, when I left multiply with, okay, so what do we get here? We get here something like alpha 1 h11 minus E plus alpha 2 h12 equal to 0. We get this equation. Right? Now what I am doing is, I am left multiplying by my other zeroth order wave function, psi 2 0. Same thing. So psi 2 0 comes over here, psi 2 0 comes over here, encounters H operator. So here I get something as alpha 1 H 21, right? Psi 2 is coming, so psi 2 H psi 1, so H 21. Again psi 2 is coming, energy is a constant, psi 1 0 and psi 2 star 0 is orthogonal, 0, nothing. Here again, same thing, psi 1 H psi 2, fine, psi 2 H psi 2, psi 2, I multiply psi 2, psi 2 H psi 2, so it gives me H 22 minus E. So this is what we get. So far so good. I have got these two equations. This I will call as equation A, and this I will call as equation B. So what have we done so far? Describe the system, contemplated, tried solving H psi equal to H psi, and this is what I should be getting. Fine? Okay. Now comes the interesting bit. Can I get this equation over here, these two equations over here, and sum this equation together because I have to solve them simultaneously, right? And I write a matrix equation as so I'm writing these two equations in the form of a matrix. This matrix multiplied by this matrix will give me 0. So you understand why I have written this? So see, row into column, row into column. So this is a 2 cross 2 matrix. This is a 2 cross 1 matrix. So when a 2 cross 2 matrix multiplies with a 2 cross 1 matrix, what do we get? We get a 2 cross 1 matrix, which will be a row matrix. Okay? So in the upper part of the row will be this equation, you understand? And in the lower part will be this equation, and both of them will be equal to 0. So I can write this as this. Fine? Now to answer your question which you asked way back. The easiest thing which we can do is we can say that alpha 1 and alpha 2 is 0. That's the easiest thing we can do. Alpha 1 and alpha 2 is equal to 0. This solution is known as a trivial solution for a set of simultaneous equations.
Yes.
To get a non-trivial solution, what what do we have to do? To get a non-trivial solution, we have to take this chunk and solve a determinant of the same name. We are allowed to say that. And make it equal to 0. So, what was the easiest thing? Take this piece and set it to 0. So, if alpha 1 and alpha 2 is equal to 0, then there is no perturbation. My systems are the same as it was before. My total system, my total wave function vanishes. My total wave function vanishes if alpha 1 and alpha 2 is equal to 0.
Is it practically possible to avoid?
No,
It's not possible.
it's not possible. It means that the wave function doesn't exist. I've given such a perturbation that the wave function doesn't exist. So, it's a trivial solution. To get a non-trivial solution, we have to solve this because this part should be equal to 0 right now. Now, if I solve this, solve this big chunk, what do I do? Solve the determinant and tell me. What am I going to do after I solve this? Like, what is the equation which is popping up? Are we getting something like that after solving this? Haven't solved it yet, we have just cross multiplied. Are we getting it? Just do it and see. Then we know. You getting that? Now,
যদি আমরা একটা পার্টিশন দিই এবং তাতে হ্যামিল্টনিয়ানটা চেঞ্জ হলো
yeah.
তার করেসপন্ডিং যে এনার্জি চেঞ্জটা হলো মানে এনার্জি যেটা এলো টোটাল সিস্টেমে শুডন্ট দ্যাট অলওয়েজ বি বাই আইগেন ভ্যালু
Yes.
হতেই হবে
H equal to H.
হ্যাঁ মানে এইচটা কিন্তু মানে আমি যদি ফর্মুলেট করতে পারি হবে ম্যাথমেটিক্যালি
ওটাই তো চেষ্টা করছি।
তাহলে তো সবসময় আইগেন ভ্যালু হতে হবে
আমি জোর করে করছি ওইটা eigenvalue equation. There is a big system psi. I'm saying that the Hamiltonian is this, and now I'm trying to solve H psi equal to E psi.
যদি আমি ঠিকঠাক করে করতে পারি তাহলে এইচটা ইকুয়ালস টু ইকুয়ালি যোগ
Yes, we are trying to solve it and see how this E looks like. You are correct saying that this is the formulation. So, and his question was that how do we know that this is an eigenvalue equation? I'm saying a priori it is an eigenvalue equation. Solving this, getting E, putting this so that we get a non-trivial solution. And right now looking how E looks like.
I'm going towards it.
I'm going to see how is he changing. That is what I want to see.
মানে ইকুয়েশন 2 যেটা সেটা সবসময় হয় because that is what we define it to be.
Yes.
But
That is
I'm
what
also
we
trying-
start with.
But I'm also trying to find the conditions under which it will be.
How does he look like?
Obviously.
We want to see if two systems are perturbating, I mean they are interacting with each other, how is the energy fluctuating? The initial energy look like this. Initial. Right now I have given a perturbation, imposed a condition H equal to E psi, got these equations for a non-trivial solution, solve this determinant. For a non-trivial solution, solve this determinant. Got something like that. Fine. So far, so good. Okay. So there is a formula, Sridhar Acharya's formula from that says that this E over here should be something as is this C coming up? Just by using Sridhar Acharya's formula, I'm getting something as this. Fine? Okay. So this is how the energy is changing. For a one, কোনটা বল? এটা কোনটা পাস হবে? minus b plus minus root over of
4ac
b square minus 4ac by 2a.
না c টা পুরোটা b স্কয়ার থেকে দেখতে পাচ্ছি c টা
বুঝতে পারলেন কি বলি?
h1 h2 minus h1 h2
হ্যাঁ minus beta plus হয়ে গেল plus minus root over of b square minus 4ac. Okay, so this is minus, you can see that, right? It is not plus. So there was a minus term which I put inside the equation and changed it to minus. Okay? Do the mathematics. I know the answer, but do the mathematics. অঙ্ক যদি না করে পাবে কি করে? দেখি তোরা পেলাম। অঙ্ক করছিস। করিস না কর। আমি নিজেও বসেছি এটা টাইমে উত্তর দিতে পারলাম না। এটা মাইনাস লিখেছি। ঠিক আছে? Okay. So this is what we get when we are perturbating a two-level system.